A coin is flicked off a 1 meter high table traveling 2 meters per second in the horizontal direction. How long does it take to hit the ground? So how long it takes to hit the ground, we're trying to find the time. Now it's always best if you start by drawing the situation. We have a coin. It's on a table that's 1 meter high. And it travels 2 meters per second in the horizontal direction. That's its initial velocity in the horizontal direction. So it's initially going 2 meters per second when it's hit off the table. It's going to fall to the floor somewhere over here. We want to know how long it takes to hit the ground. So in this, it's best if we break up our situation into the x direction and the y direction. What do we know in each direction? Okay, a coin is flicked off a 1 meter high table. This is our delta y, 1 meters high. Now, if we start here and we finish here, and we say this is our positive y direction, and this is our positive x direction, notice how it's traveling in the negative y direction. So its displacement in the y direction is negative 1 meter. In the x direction, well, we're not sure. It's going to be the distance that it travels from here to here. If you read ahead, you'd see how far from the table does the coin land. That's asking for delta x. What else do we know? How about this piece of information? 2 meters per second in the horizontal direction. Okay. Think of a ball being kicked off at an angle. Now that ball has an initial velocity in the x direction and the y direction. But our scenario is a coin just getting flicked off the table only in the x direction, the horizontal direction. So it has no vertical component of its velocity, meaning its initial horizontal velocity is 2 meters per second. Its initial vertical velocity is 0. There's no component. There's no component that's in the vertical direction. What else do we know? Acceleration, if we ignore air resistance, in the x direction, it's 0. In the y direction, it's negative 9.8 due to gravity. So we have 3 things here. We know we could always find a 4th. So what we're trying to find is the time. What is the time? So I'm looking over here and I know 1, 2, 3 things. I can find the 4th. Remember, when we did the experiment where you dropped a penny off the table and shot one out horizontally, they landed at the same time. So it doesn't matter how fast it's being shot off the table. It could be dropped, this could be 0, or this could be 100. And we should get the same answer for t, as long as our initial velocity in the y direction is 0. So we've got to pick a kinematic equation that involves all 4 of these. So if you look at your equations, this is the one that'll work. 1, 2, 3, 4. Now we plug in our numbers and solve. So what I'm trying to do is get the t all by itself. Zero times t is just 0, so we can ignore that. Now, if I want to get this t all by itself, I can divide both sides by this. I'm almost done. now I have delta t squared. These divide to give me 1. So now I've got delta t squared is negative 1 all over 1/2 negative 9.8. So to find t, I need to take the square root of that number. And you put that in your calculator and you get 0.45 seconds. So we found our answer for A, 0.45 seconds. So we can put that in here. Now we know our time is 0.45 seconds. And our second part is how far from the table does the coin land? How far, it should say how far from the base of the table. So this distance from here to there. Now, once we have 3 quantities, we can always find a fourth. So you can use the exact same equation as we had before. Now if we notice acceleration in the x direction, this value is going to be 0 if there's no air resistance. So 0 times any number is just going to give us 0, so we can ignore this quantity. So what we have left is delta x is equal to Vix divided by delta t. We want to find out what delta x is. Initial velocity in the x direction, 2 meters per second. We just found the time to be 0.45 seconds. So our displacement in the x direction is 0.9 meters. So it's going to land 0.9 meters from the base of the table, and it's going to take 0.45 seconds to get there.